Hello, my name is Melanie Pincay. My partner is Emilio Moreno, and we are going to talk about boost converter. A boost converter is a DC to DC power converter that steps up voltage from its input to its output. It is a class of switch mode power supply containing at least two semiconductors, a diode and a transistor, and at least one energy storage element, a capacitor, inductor, or the combination of two. To reduce voltage rise, filters are made of capacitors are normally added to such a converter output and input. Now we are going to talk about the two stages of the boost converter that are when the boost converter switch is on and when is off. When the switch is on, the switch is closed, as we can see in the figure where the diode is open because the cathode voltage is higher than the anode. The key principle that drives the boost converter is the tendency of an inductor to resist change in a current by creating and destroying a magnetic field. In a boost converter, the output voltage is always higher than the input voltage. When the switch is closed, the current flows throughout the inductor in clockwise direction, and the inductor stores some energy by generation a magnetic field. The polarity of the left side of the inductor is positive. Now, when it's in the off stage, the switch is open. The current will be reduced as the impedance is higher. The magnetic field previously created will be destroyed to maintain the current throughout the load. Thus, the polarity will be reserved, means left side of the inductor will be negative now. As a result, the two sources will be in series, causing a higher voltage to charge the capacitor throughout the diode. In the case of the voltage across the inductor, is it the difference between the output voltage and the input? Thank you.
Uh, Hello, my name is Emilio Moreno. We're going to talk about a few benefits and application of the boost converters. Now we have a high gain of voltage inefficiency, which is produced by a low operation duty cycles. What is this? We have two operation cycles according to the behavior of the switch. We have a continuous conducting mode when the switch is off, and a discontinuous conduction mode when the switch is on. According to this, we're gonna have two equations of the gain of voltage. We're gonna have an equation for the continuous mode and equation for the discontinuous mode. Both equations are based on the fact that the inductor the energy of the inductor are the same is the same, sorry, for the in the beginning and in the end. So we're gonna see that the gain of voltage in both cases will be related to the input and output, but in the second case we're gonna have the implication of the diode, and the both energy storage element. Now we're gonna have a cheaper design. What we say this? In the auction market, we know that the simplification of any design means a higher efficiency and a higher feasibility of production. So how we can say that this is cheaper? Because we have a simple circuit design. If we see this, we only count is a simple circuit that can be easy understanding. And why is that? Because it has just a few semiconductors. Two semiconductors, which is one the diode and the switch, and one energy storage element, and two energy storage element, which is the inductor and the capacitor. The resistance doesn't count because there is the output voltage. Now we have an unidirectional output current. This is explained by the law of inductance, which says that any inductor in a circuit resist the change of current. So as long as the inductor is still working on the circuit, we're gonna have an FEM forced in opposite direction that the current is going through this coil, the oil of the inductor. This is the law of inductance. We have few applications of the boost converters. We have the LED drive. We have LED drivers, which is just a DC to DC setup converters that delivers a regular output of voltage. That is, in a few words, the same normal working of the boost converter. So the device drives a string of wirelets are these ones. These ones are the wirelets connected in series and provide the regulated current to control the LED with inherent uniform brightness and matching. So according to the output, if the output is regulated, three of them are gonna have the same bright. Now we have the hybrid electric vehicles. Why we use the boost converter in this case? Because the electric vehicles need a lot of voltage. So if we don't use it, we're gonna need a lot of power cells to create these kind of motors. For example, if we have a motor that works with 500 volts, without a boost converter, we're gonna have across uh, approximately 400 power cells. But with the use of boost converter, we're just gonna need near 150 or 200 boost batteries. We can gain 202 to 500 volt in each one, so it's much better. Now we have battery power systems. What is that? We know that most of the DC power supplies comprise of a large and heavy step-down, means transformers, diode rectification, either full wave or half wave, and filter circuit to remove any ripple content from the rectifiable DC output. So now we're gonna see that this is just a sample boost converter, and we're gonna have because the present of the inductor, we're gonna have a regulated output of current, a small one, because that is one of the function of the boost converter, and we're gonna have here a continuous cycle, which is why the capacitor acts like a filter in a pole impulses. Is with the voltage its pulses, they can regulate the output, and we can in this load could be changed for a potentiometer that can actually regulate the output. As long as we have a potentiometer here, we can regulate how much is the voltage we're gonna take out as a power supply source. Thank you.